Cool. Yeah, I guess honestly, I'll try to take a very business and entrepreneurial approach to some of what I've gone through and some different stories. Boiled down, if you're having a hard time grasping open hardware, one of the things to think about is that a patent is only as good as your ability to defend it. If you're not willing to put the time and the resources into defending that, maybe a patent's not for you. A lot of times when you have a startup organization, you don't have a lot of capital, it's going to eat your time, it's going to eat your funds. And if you're not willing to spend that, then, well, you really don't have any business doing a patent to begin with. But a little bit about our company. So there's just over 50,000 of our machines in circulation today. The brand is about 13 years old. We've got 45 employees in Fargo, North Dakota. All of our company functions are there, whether that's engineering, software development, sales, support, fulfillment, you name it. It's really slick to have your company under one roof. You can make a lot of things happen fast. And then same day or next day business shipping. So open source hardware and 3D printing. As you listen to a lot of our speakers today and the topic in general, it's pretty clear that the two are quite intertwined. They play off each other nicely. In a lot of ways, I think 3D printing has helped open hardware accelerate. In the past, with open source software, sure, you could email or share files quite readily that way, but it was very hard to do with matter or atoms, as Alicia mentioned earlier. So 3D printing allowed you to do that for the first time. This is especially true with our machines, which are 3D printed, or at least feature a lot of 3D printed pieces. So what are some benefits of the open source hardware? Innovation acceleration. So you've got faster iteration cycles with 3D printing and the community. Cost reduction. Lower research and development costs through shared efforts. Customization and flexibility. They're easier to mod and adapt to specific needs. And then community. You've got a much larger community of experts and enthusiasts, which can be very, very valuable for a company that's not massive. At 45 people, we're not a huge company, but some of our competitors may have 1,900 employees. That's a little bit different R&D staff if they've got 300 and some guys that can't talk about what they're doing because it's completely proprietary. Whereas we might make a couple phone calls to some developers in Detroit or Seattle, and if it interests them, some of them are pretty adamant that they get $5 for a cup of coffee. It's really an interesting ecosystem. Others are happy to work on an open source project for a consultation fee. So you can still pay people to help you work on your open source project. That's not a problem. It's kind of what you do with the files and what you do with the product after. So the first Lulzbots I show here are actually kind of an interesting story. This is not a machine that we build, but rather the origin of a new machine that we carry today. We now build the Lulzbot Pro XT, which has a 2-foot tall build plate. These were the precursor. This is a machine that was built by a company that took our files, modified them, and made a double high printer. This was called the Tall Boy. It was used for prosthesis. Check sockets for above the knee and below the knee amputees were especially popular, but that is an incredible space to use 3D printing because historically you're hand carving or you're pulling carbon fiber molds and stuff, and if something screws up or breaks, well, you basically start over a multi-day process. But with a digital scan and a 3D print, something happens in that process, you can just recreate it again. So this became an incredibly practical machine for that application. Some other examples of this are some really weird machines we've been messing with this past summer. There is our Pro XT platform again, but this time outfitted with a pellet-fed extruder. 3D printing is largely filament-based at the desktop level, which is nice, but it can be limiting. You think of companies like Samsung, which have incredible plastics and polymers department. They have blends of plastics that will never be turned into filament. there's no business case for it, but they have the pellets, they have the polymers that they use for their TVs and casings and such. What if they could 3D print out of that exact grade material? And that starts to become the business case for why pellet fed. The machine on the right is very interesting. Dr. Pierce covered this a little bit in his presentation, but we're using a bioprinter, which usually you're printing with like collagen and alginate, different bioproteins, but here we're using a photopolymer. We're essentially resin curing, and we've built a special chamber for that. It's weird to do resin printing in an extrusion-based machine, but it does work. And because you're able to modify and do those things, it's pretty exciting. 3D printing itself, our machines are printed. The machine you see on the right-hand side, there's our Taz Sidekick. We developed that completely during COVID at a time where supply chains were cut off and very difficult to get things. So we just kind of turned to each other and said, well, how much of this can we print? And it turns out you can print over 50% of the machine. So that's what we did. Really thought that it turned out nice. The development cycle on it was very fast. It performed the way we wanted. And then at the same time, after you get the product out, you're able to continue to rev it, continue to offer better designs for your customers. As we speak, 2 years after having this Taz Sidekick released, we're actually working on new bed corners right now. The magnetic build plates that we offer, it's kind of hard to get them to center nice on the bed. Well, we came up with a new 3D printed design that basically makes it impossible to not install it properly. So if you have a Sidekick, you can print these new bed corners, bolt them on the machine yourself. You're not really out too much, maybe the cost of the plastic, and it works pretty well. We also talked a little bit about community. The product you see here was derived from a work by Tim Pierce. Now, Tim Pierce didn't create a certified project or anything about it, but you can definitely empower your community and your end users by featuring them and talking about, hey, so-and-so thought of this. Likely, whether it's in forums, Reddit, Facebook groups, they recognize Tim Pierce as a name. So that's pretty exciting for people to get to see that. You'll find that some people, engineers especially, they really do enjoy that accolade. The patent can be quite difficult to get sometimes. So, here you have a community member that came up with a great idea, and yeah, it's not going to go through a patent process, but his name's tied to it, and he can reference that, show his friends, family, coworkers, you name it. So that's pretty exciting. Cost reduction, so shared development. There's a few popular platforms, GitHub probably being the most popular, but we use GitLab a lot of times. When you look at our company, really, because that's what this is a breakdown of, you see our accessories, Cura LE, which is our software. We've taken and modified the open source slicer Cura to work better with our machines, at the same time still giving full attribution to the developers that have worked on it prior, as well as leaving our repository open so that if any of the development work that we've done, if they find that interesting, if they want to incorporate it in their code, they're more than welcome to do that. Cura is a little bit unique in that way. We do a lot more work on Marlin, which is the firmware for our machine, the actual brain that's running the 3D printer. And a lot of times when we find something that's off in Marlin or it's not quite working right, we'll contribute that back to the main Marlin group, and they'll make the decision if they want to merge that with the main Marlin project, or if it's something that we'll maintain separately on our machine. Maybe it's a feature, one we built this past week was called Present Bed. The Taz Workhorse machine that we do homes to the left, right, and then all the way back. But the problem is if your printer's home to the back, you can't get a print off easily. So we created a new button that is called Present Bed. After homing, you can click this Present Bed, and the bed comes forward, and you can retrieve your print. Other people may find that useful. If they want it, the code has been created for it. They're more than welcome to incorporate it in their machines as well. And then GitHub, we've just started doing a little bit more. That is more popular for a lot of projects. I mentioned Marlin, but another firmware that's getting to be pretty popular with 3D printing is called Clipper. This is where a lot of high-speed 3D printing is coming out of right now due to a feature called input shaping. Though from Clipper's development and work in input shaping, we also see Marlin is now starting to incorporate input shaping. So an open source ecosystem kind of allows these to grow and build off of each other without leaving either in the dust. And then this is our slicer. So slicing software, as far as the 3D printing process is concerned, so you've taken your CAD object and you now need to run it on a machine. The slicer is what is going to allow you to make decisions around how that gets accomplished. I'll go into a little segue here for those of you not familiar with 3D printing. It's done by layers. So you have layers of plastic just like bricks to build a house. A concrete block is built bigger than a small brick. So if you use concrete blocks, you maybe only need 100 to build a wall. But if you use bricks, you're going to need 500. And the amount of time to lay them varies between the two. 500 bricks takes a lot longer than 100. You can do the same with a slicer. A finer layer height means you might have 10,000 layers in a given print as opposed to 100 with a thicker layer. So decisions like that can be made by your slicer. These are all different open source projects. You can find it under the About tab in our software that we're referencing when we build this. We do not have a huge software development team at all. At this point, it's basically 2 guys. We are a manufacturing-focused organization. So how great is it for us to be able to build a machine, support it with a software that's catered to our machine, but then also not have a team of like 10 or 15 guys that we're paying pretty good money to maintain. At the same time, Jamie, one of the main developers for Mainline Cura, very friendly, very happy to answer questions. We're still a series behind right now, but we're catching up. So we'll get up to the newest version, and then we'll get to reap a lot of those same benefits when it comes to machine efficiency. And then customization and flexibility. I talked about the machine on the right, our Pro XT, a little bit, and how that was largely made for the prosthesis industry, though it is popular with rocketry and other tall objects as well. Another machine like that would be our long bed printer, which you see on the left. This is not something that we would have made of our own choice. It's very expensive to build a machine like that. And there's a lot of things you have to think about when you're working over a 2-foot build volume laid down like that. But you do get a lot stronger parts because they're continuous layers. 3D prints are kind of like pieces of wood when it comes to grain structure. If you've got long grains, it's a lot more likely your part is going to be strong. If you have a bunch of chopped grains, it could break along them. But the long bed printer came from a customer request, and that's why I say customization. They asked if we could start making something larger, and we thought about this a lot and worked on it, but we were able to modify and make that platform work quite well. Community is another one. So I touched on this a minute ago. This is just some examples of different places you might interact with your community, whether it's an official Facebook user group, on the forums, or even a Reddit. These are all places that people might give you ideas. They may lament things that they don't like about the machine, or they might tell you stuff they love about the machine. So as you go to develop your next version of the machine, you either make sure to keep those features in there, or you change the things they don't like. Oh, filament loading sucks, or I can't get it off the bed without chipping away or carving into the surface. Those types of things led us to doing a magnetic build plate system, or a tool head that you could easily lock or unlock to load filament. Repositories are another big thing. The page I'm showing here is Thingiverse. Thingiverse was on the scene very early on with 3D printing. You could essentially go to Thingiverse and search it almost like Google for anything that you could possibly want to make, and chances are somebody has made something and it's out there. At this point, you can look at the open source licensure on it most times. The only one to kind of be aware of is if it has an NC or non-commercial license on it. Don't start printing that and selling that. That isn't their intent. Their intent is to share the design with you so you can iterate over the top of it. But we have a Thingiverse page, so these are all free, any of these files, if you want to build some of those Lulzbot stuff. And then we have many, many other files, some of the files for our machines and such. Yeah, I should mention kind of on that GitLab page and where we host our source is really what we call it, the extent that we go to there. If you can imagine having a machine where every single wiring harness diagram, how to build it, the sheet metal diagrams that you would send to a fabrication shop to make them, the powder coat specs, the packaging, all of the printed parts. We heard a story a little bit earlier today where part of the machine broke and they were able to hold it together enough to essentially make a replacement part. That is possible with machines like this. If you got a roll of duct tape and you can at least get the machine through making its replacement part, the actual file and everything that you needed to do that are free. They're readily available. Whether it's trying to figure out which size bolt this was supposed to be, or how we got a particular piece to hold up. You can see that. And usually you can see revision history too. Maybe this part is on our 4th revision. And as you go to inspect your printed part, you're like, well, geez, I only have revision 2. Maybe I want to print this newest one. Maybe there's some reason they upgraded it. So the business of open source hardware, why would you want to do that? How do you work with open source hardware in the business arena? Product sales, that one's pretty self-explanatory. If you're selling the hardware itself, supporting the product, let me tell you, it's a lot easier to support open source hardware when you don't have to worry about what pictures you're showing, when you can literally send them the engineering diagrams, or they can call you up and have a problem with an extruder and you can have them check, do you have the correct current flowing to that extruder? It's supposed to be 9.5 and they don't, or they've done something to their machine. Being able to freely share that information with them helps them solve their issues a lot faster. OSHWA certification, this is something that you can offer your hardware under and carry those types of things, which gives a lot of trust to your open source hardware. Compatibility, being able to take your existing hardware solutions and work with multiple vendors. This is really nice when it comes to pivoting, when it comes to working with other companies that maybe aren't so large. The 3D printing industry has that quite a bit, where yes, we're a company of 45 people, but some of our suppliers only have 5 to 15 employees. Well, what happens if they don't make it? What happens if they go to business? What's the plan B there? We can't have that kind of risk. We look at stuff a little bit differently, of course, now with COVID. So these are very real questions to have about your supply chain. And then monetization, figuring out effective ways to generate revenue without compromising the open source ethos. I guess I could show kind of some of these pictures too. The one on the upper left is a company called OtterBox and how they've essentially made different parts for their phones, some more prosthesis, componentry on the right, a 3D printed heart on the bottom left, and then some components for helmets. You may recognize a few of these customers that we do business with daily. Whether it surprises you or not, I'm not sure. They certainly don't mind open source hardware. Having the right to repair and fix their stuff means that they can. A lot of times, hours or minutes in some of those assembly line type companies is thousands and thousands of dollars. If you're not waiting 3 weeks for something to be machined out of aluminum or Delrin and you're able to make a specific part to get the packaging line up and running, you're saving significant money. And it's sometimes not how people think. Jigs and fixtures are a big part of how 3D printers have earned a place in modern industrial production. It's not always end product. You aren't necessarily going to buy your Ford product and be able to touch 3D printed parts in the cabin. But in the background, they've probably helped. I can think of numerous ways that they've really improved that whole process. Picture, if you will, you're trying to put bolts in an engine under the hood, and you drop a bolt in the engine bay, and now you have to tear the whole thing apart. Well, what if you could 3D print a whole tray with funnels that go exactly to where the bolt hole needs to go. So at the end of the day, you drop the bolt in, it self-aligns and can only go in the hole it's supposed to. That's the type of jig and fixture that in the past would have been cost prohibitive. We talked about even some examples earlier today of just how great the cost reduction is, both 3D printing as well as doing open source design. It's very freeing, and these companies are seeing the value in it. Another portion of our business, so this is on product sales, turnkey print farms. So you want to do 3D printing, or your educational institution wants to have 3D printers for students to use. We don't know where to begin. How do we get started? How do we make sure we have everything they need? And that's where turnkey print farms have really kind of turned into a nice avenue for us. We make all of the aluminum components, powder coated, polycarb sheets. Depending on the material you're printing, sometimes you want to enclose the printers just to keep the plastic warm a lot of times. Otherwise, it can warp, especially with ABS as a material that likes to warp if you don't keep it free of drafts and warm. But that's one thing we do to monetize. We make our own parts with our machines. This is a huge cost reduction for us. We use 300 of our machines to make our machines. Yeah, if you can imagine, just like trying to print a PDF, you can print parts, and you can rev parts. The mold making process is very high risk in the sense that you have to have it right the first time. And you may have weeks leading up to that to make sure that it is absolutely right before your company cuts the check and you make a mold. 3D printing, the risk is completely gone. Print it, break it, print it, break it, print it, break it. Okay, this one's starting to work. That's fun. You end up with a better product overall. We've also started leveraging this 3D printer farm this year to do more contract manufacturing. So on the monetization side, taking any spare capacity we have and using it to pick up 3D printing jobs. More and more you see entrepreneurs starting companies where they need a 500 to 1,000 piece run. Well, at 500 to 1,000 pieces, they don't have the volume to justify molding. They don't have the established product brand yet. So 3D printing is a great solution to get going and start building their product. Bioprinters, we've touched on that as well. Right now, bioprinting is a lot of research. There's not a lot of companies doing this at scale. I think we'll see that change eventually, but for now, it is a lot of research. So it's good to stay kind of abreast of what opportunities are out there and just be there for special requests. One really cool project, we had a chance to work with the USDA on their honeybees. So that was an application I never thought that our bioprinter would have anything to do with, but they actually use the bioprinter to feed them, feed the larvae of queens. One of the things they have a lot of problems with is colony collapse, and if they can incubate and raise queen larvae, typically this is a process where you're hand pipetting and feeding each larva to keep it alive. When this starts, it's like every 20 minutes you have to do that around the clock, and then every 2 hours, and then it gradually gets better. But if you can program something like that and run it on a machine, it's going to extrude the correct amount at the correct time so that those honeybees can make it. Application I wouldn't have saw coming, but yeah, we can make our machine do that. More bioprints, 3D printed hard valves, our company logo. So it's a promising field. We'll see what happens with it. At this point, again, you don't have many commercial enterprises that are producing 3D printed bio stuff on a large scale. Not many yet, but we'll see how that goes. So supporting our machines. This is another very nice part with open hardware. We actually call this our OHI, or Open Hardware Assembly Instructions. So all of our staff that are assembling our machines, they can actually log into this website. You can log into this website. There is no password wall or anything. Click on any of our machines, go to a particular part on our machine, whether it's the X-axis assembly or the tool head, and see the pictures step by step with the part call out for how to put it together. If there's a jig, how to use that jig, where to put Loctite. A lot of times if you want to go the other way, you can actually just scroll in reverse, and now you're looking at how to take the machine apart as well. But this is a phenomenal thing to be able to send somebody. If they call in and they've got issues with a particular part of it, and you can save, I don't know, like a 2-week, 3-week turnaround time on a warranty claim, or hours of trying to troubleshoot it over the phone, or them going back and forth with photos. If you can just send them a link to this is that part of your machine, we'll talk you through it. Does this make sense? Oh yeah, oh man, works great. Then they can fix it themselves and save you a lot of money on the supporting side of your machines. So at the same time, being on GitLab or GitHub, people are able to create issues. This gives them a chance to have an open dialogue with your company about errors that they found. If you don't give them a platform to do that, you're basically left to them emailing info@, support@, sales@ your company, and then trying to figure out what they're talking about. But if you give them an actual platform that's built into where you do your development, they'll just post issues, and you can work through that list and prioritize kind of as you see fit. Sometimes it's a critical thing that they find. Other times it's just they don't like that the button is green, which you kind of just filter those as you see fit. I mentioned OSHWA certification. These are some of the certificates we hold. You see the bioprinter at the top of that list. So, very good thing to do. I mentioned compatibility with different vendors. Our tool heads are kind of a prime example of this. Many of the vendors that you see here are interesting in the sense that they have both open source hardware, and some of them have patented hardware at the same time. But it does seem to work pretty good working with these companies to develop different tool heads. Again, if any one of them was to go out of business, having a good relationship with the others allows us to continue as a company and be a lot more resilient. I mentioned tool heads a little bit ago. I think this is kind of one of the crux pieces for why our machines do so well, is because people do different things with them. I mentioned the bricks earlier on small layer heights or tall layer heights. You can kind of see an example of what that might look like. But at the same time, somebody may just take our 3D printer and use it as a movement system, put a DLSR camera on it and check the health of corn plant leaves by running it back and forth, just doing inspection work. Well, they're not even using it as a 3D printer. They're using it as a camera inspection system, but they like our movement system. So that definitely ties into open hardware. They wouldn't have been able to adapt it quite as easily for that application had it not been for that. It's kind of surprising. When people do start on those projects, they usually ask a lot of questions, and we help them figure out where the CAD is for maybe the mounting points, or where they need to have their various pins to get the harnesses to play nice. Our ERP system is also open source. We use a product called Odoo. This was born of the Open ERP project. We like it a lot. If something is not built in here, we develop it ourselves. Of course, the only fun part of that is sometimes you can get ahead of an organization. We're currently on Odoo 13, but we'd like to move to Odoo 17, but we've made a lot of custom modules for Odoo 13. So then you get to figure out, how do we do that? And that's kind of a business decision. Do you build the second platform in parallel, and then when the time comes, switch over? Do you try to port most of it? But there's a lot of the business software side too that can be open source, and you reap a lot of the same benefits that you would with open hardware in terms of being able to get what you want out of it without spending a ton of money. Some competitors would be like SAP, which is a very, very expensive system, Epicor, Microsoft Dynamics to an extent. But yeah, ERP systems can be expensive. So open source solutions aren't bad if you've got a little bit of coding know-how or know how to type something in ChatGPT to get it to do something. ChatGPT is very, very good at coding if you ask it some questions. Solving problems. This is a John Deere planter. We had a farmer that was doing seed plots. They wanted to use their modern planting equipment, which had everything they needed from a GPS standpoint, and accuracy with air seeding, but it had to be ran off the central hopper, which is in the center of that planter there. But when you're doing a seed plot, you're trying to plant many different varieties of seed. You don't want to plant just one variety. So essentially what they did here is 3D print a little hopper instead of a cap for that portion, and then you cut off the air line, and then you just pour the varieties of seed that you wanted in each row in this hopper. So now you have some modification to make it useful for planting seed plots. Yeah,